All right, the last assignment, one thing we did when we were using synthetic division, we found the factors because they already gave us the what? They gave us the roots to plug into the equation. Okay, the rational root theorem helps us figure out all the possible, right here in your journal, right, all possible roots or solutions. Okay, so the rational root theorem is going to bring, and like I said, don't write all this down. What we're going to do is we're going to label some things. Okay, so I want you guys to understand that this coefficient right here, and even though you can't see it, there's a coefficient in front of the x. Put a 1 there. I want you to call this number, I want you to label it as the variable p. And I would like you guys to label this variable q. And if you read through this, you'll see it says p is a factor of this right here. If you look under paper, all right? But I want you guys to understand, if you take the factors of p over all of the factors of q, that will, I'm going to put plus or minus, all of those factors, this will be all the possible roots that could go into this big, long polynomial function. Okay? So we're going to find all the possible roots, and then once we list all the possible roots, we're going to start testing them using synthetic division. Okay? So the first thing I want you to think about is, what are the factors of 12? All right, so let's think about the factors of 12. All right? We have 1 times a 12, obviously. What else?
2 times 6.
2 times 6.
3 and 4.
And 3 times 4. So what I want you guys to do is I want you guys to put plus or minus. We're going to list all of those in order. 1, 2, 3, 4, 6, and 12. And the denominator says all the what? All the factors of q. Well, there's only one factor of the number 1. That's just 1. So the possible roots that could go into this expression right here, the possible roots are plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, and plus or minus 12. These right here, these are, when it says list all the possible roots, those are all the possible roots. Okay? Now, what we're going to do is we're going to test them to see if they actually work. So here's what we're going to do 2 in your journal. You have plenty of room to work in your journal. So if we mess up, this is where you're going to have an eraser if we choose the wrong root. So we're going to, right now, we're going to list our equation. The equation that we have is x cubed minus x squared minus 8x plus 12. All right, and this is all equal to 0. So if we were to do our synthetic division, all right, we're going to list our x cubes, then x squares, x to the first, x to the 0, 1, negative 1, negative 8, 12. And once again, on our last assignment, we had one, we're like, well, what am I going to use? We can work our way what? Work our way backwards. So what do I want this to be? I want this remainder to be a 0, and I want this to be a negative 12. So we need to get somehow to a negative 12. So how about this? You guys select a number, and we'll test it to see if it works. 3. Let's test 3. I'm going to put a 3 here. Bring down the 1. 1 times 3 is 3. Negative 1 plus 3 is a 2. 3 times 2 is 6.
No.
Is that going to work?
No. Can you try with negative 3?
Negative? We can try negative 3.
Can we try 12?
You want to try 12?
Yeah, let's try 12.
Okay. 12 times times 12 is,
12.
oh, sorry, hold on. I messed up here.
Or try negative 12. One and then 6.
Or negative.
We'll try negative. Bring down a 1, that gets me a negative 12. You see how that's not gonna work.
Try positive 12.
Okay, now we'll try positive 12, but that's it.
Okay.
Bring down the 1, 12,
That's negative
11.
that's 11, that's gonna get me 132, we're way out of the ballpark. Alright, so hold on a second. Obviously, we're using big numbers right now, and they're not working. Not very well. So,
You have to go with -3.
negative 3?
Yeah.
Okay, we're going to try negative 3. We're going to see if this works. Here we go. Bring down the 1. Elise, you said it?
Yes.
And
Well,
Liz
I mean,
said it.
Liz said it. But
Liz
I
said
said,
it.
I was like,
You agree?
I didn't know if it would be right. And I didn't like, you're stupid. You would never say that.
That's not negative 3.
You're killing me here. You're killing me. All right, so negative 3 times 1 is a
3.
negative 3. Add those together.
No.
Negative 4. Negative 3 times negative 4 is a positive 12. And negative 8 plus 12 is a 4. Negative 3 times 4 is a negative. And it works.
watch out.
All right, we just found, everybody. We just found, not found. We found a root. Very good. We just found a root. Now, what does this represent? This represents the x squared. This represents the x to the first. This represents the x to the 0. So what do we have left? We have what? An x squared minus a 4x plus a 4. We're going to do it again.
Wait, what was negative 3?
That was our root. That's one of our answers. That's one of the numbers we're going to put into our set. So we know negative 3 works.
Do we write?
So now we have to find.
1 second. Now, this is our expression that we have left. Right now, one of our roots is negative 3. This is what we have left. Okay? So we have how many x squareds? 1. Negative 4 and 4. Now, once again, we're going to work our way what? Work our way backwards. So this has to be a what? 0, right?
So that has to be a -4.
So think about this. What number here and what number right here, these two numbers multiplied together have to equal a...
4.
Try 2 up
2.
there.
No, -2.
No, try
Negative
2.
2. I just
Okay.
did it in my paper and it worked for me with the -2.
Okay, so you go at her, try negative 2.
Okay, how about this?
Then
What? Okay, how about this? I'm just going to make an executive decision right now.
positive 2. Let's go.
We'll do positive 2 right now. We're going to bring the 1 down. 2 times 1 is
Yeah, positive
2.
Negative.
That ends up being a negative 2. 2 times negative 2 is, and it works.
What I tell you, my bro.
So what's our another root? Our another root is a
2.
2. And what does this right here represent? This represents x to the first. This represents
X to the 0.
x to the 0. So we have one number, we have an x minus a 2. So right now what I'd like us to do is we're going to list all the factors together. Our very first factor, Elise, our very first factor, all right, we're going to take this -3, we're going to make our first factor.
Okay, I get what you're doing when you're doing it like in the little.
And, yeah, using synthetic division.
I get that part, but what do we do? Why are we doing so many?
Because we have to find all the roots.
And
Okay?
how do you know when you're done finding all the roots?
I'm about to tell you.
Whenever
All
you
right?
get
So,
0.
one of our factors was x plus 3. One of our factors is x minus 2. And this last expression right here is x minus 2. That's what we have.
Would you get x plus 3 at?
I'll
Why do you
explain.
get X on each one?
Hold on.
Go explain it.
I'm trying to explain. By the way, if this is the root, if -3 is the root, then x plus 3 is the factor. If 2 is the root, then x minus 2 is the factor.
So,
All of this, I'm going to explain something right here. This times this times this, if I set it equal to 0, everybody, equals our original polynomial function of x cubed minus x squared minus 8x plus 12 equals 0. This right here, if we multiplied all those together, you would get back to this original polynomial function. Now some of you had the question, how was x squared, hold on, minus 4x plus 4, technically, this is a binomial, this is a trinomial, it's a perfect square trinomial. This can factor two numbers that add up to a negative 4, but multiply together to equal a positive 4. What are two numbers that add up to a negative 4, but multiply together to equal a positive 4? Negative 2 and negative 2. Alright? So x minus 2 times x minus 2 ends up becoming x squared minus
That would be so much easier.
I know, but you didn't recognize it. So yes, if you recognize it, you don't have to do synthetic division. You can factor a trinomial if you know how to factor a trinomial. However, if you don't know how to factor a trinomial, what can you use? Synthetic division.
Well, how do we know if we use synthetic division, how do we know if there's 2? Like, x minus 2, x minus 2, how do we know there's 2 of them?
Alright, so here's what we did.
Because we didn't.
The final answer, everybody, for the roots. The final answer. One of our roots was a negative 3. What's the other number you could plug in here to make it equal to 0? A positive 2. Those are the actual roots. So your two answers, everybody. Your two answers are the actual roots and the list of all the possible roots. Get out of here. We'll see you later.